Understanding time constants and their use means understanding various forms of change. Change can be uniform or non-uniform. Uniform changes can be described by rates, non-uniform changes by time constants. Objects move because of force. If the force is constant, the change can be calculated as a constant rate, such as miles per hour. Fluids move because of pressure. If pressure is constant, the change is measured as a constant flow rate, such as gallons per minute. Voltage moves charge. If voltage is constant, the charge can be measured in amps, a constant rate. And if temperature difference is constant, the flow rate of heat can be measured as calories per second. When these forces or prime movers are constant, the rate at which the objects, fluids, electric charge, or heat change will also be constant. A constant change always produces a straight line on a graph. Non-uniform changes occur when the force, pressure, voltage, or temperature difference is not constant. In other words, the amount of change itself is changing. In mechanical systems, it could be the amount of displacement an object experiences when a vibration is damping out. In fluid systems, it could be the changing flow rate when a pressurized tank is filled or emptied. In electrical systems, it could be the changing flow rate of charge into and out of a capacitor. And in thermal systems, it could be the changing flow rate of heat out of an object cooling to room temperature. These non-uniform changes always produce a curve when plotted on a graph. This curve is the tool for finding the time constant for any system. Once this curve has been plotted for any change, simply find that magical point at 37% of the maximum value. Drop a line to the time axis and you have it. We've seen lots of graphs in this unit, but actually only 3 versions of the exponential curve. One where it starts at 0 and increases towards infinity. That's a runaway situation and rarely happens. The second version of the curve is an exponential decay. This type of decay could be mechanical damping, a fluid escaping from a sealed tank, a charge leaving a capacitor or an inductor, or the flow of heat out of a cooling object. Time constants measure how long it will take for these changes to be 99% complete. The third version of this curve is when the amount of change rises to a maximum value. This could be the flow of fluid into a sealed tank, the flow of charge into a capacitor or inductor. The time constants for these curves measure how long it will take to reach 99% of the maximum value. The reason we say 99% is because the exponential curve essentially flattens out and never meets the maximum or minimum value. So how can these systems operate if vibrations never stop, tanks are never emptied, capacitors never discharge, and materials never reach ambient temperature? Well, there's always a section where the slope is very steep. That's the time when the changes are occurring most rapidly. If the changes needed within a system are within this section of the curve, they will take place quickly, and whatever's left over is not significant enough to deal with. In other words, this is where the process is considered complete for all practical purposes. It's like trying to capture a rabbit with a trap. If the rabbit approaches the trap in an exponential way, covering half the distance to the trap with each hop, theoretically it will never reach the trap. But it does come to a point where it's so close, the remaining distance is insignificant. And if you don't pull the trap, you've lost the rabbit. Here's a parting thought. It's been said that since vibrations in the air decay exponentially, they never completely die out. That means that every sound that's ever been made, Every word ever spoken is still floating around in the air. We just don't have microphones sensitive enough to hear it. So every word that you've heard in Principles of Technology is still bouncing around the room. So if you think you've heard the last of my voice, listen closely, and you might hear the echo. This program was produced under the direction of AIT at the facilities of Telemation Productions and is part of Principles of Technology. Developed by the Agency for Instructional Technology in cooperation with the Center for Occupational Research and Development and in association with a consortium of state and provincial vocation education agencies. Together, serving education.